Okay, so study unit 2 starts on page 20. Here they're looking at linear equations. Okay, there are some workings here that you need to be familiar with. So I'm going to summarize a bit of this. Matthew, how much maths did you do before going to UNISA?
So I did maths literacy at school, but I mean, I think, can I be honest with you? I think during school I was very lazy. So I thought, let me just try the easier way out and do maths lit. But I mean, if I can do it, I did DSC.
Yes. Which one did you do? 1520?
No, 1630.
1630, yeah, okay. DSC 1630 is financial mathematics. That's looking at using the calculator to do time value of money.
Correct, yes. I think, yeah, that's pretty much basically the most intense maths I've done.
Okay, but that maths is different to algebra and linear equations and that type of thing. So that's why I'm asking, because if you did DSC 1520, this one is the, inverted commas, the pure maths module. Okay, so you said you did DSC 1630. 1630 is just time value of money, basically. It's financial mathematics.
Financial maths, yes, financial maths. It was just, yes.
Yeah, okay, so if you've done that one, great. You haven't done this one, right? The pure maths.
No, I haven't. But I mean, I can just, I'm sure I can type it in onto Google and get like notes from somewhere and just go over it. But I mean, with maths, I mean, if I do it now, I mean, I'm more mature than what I was. So I think I can click or just do a bit of practice and get it.
Yeah, well, I'm going to summarize it because you wanted to cover calculations. There are calculations here because they talk about simple linear regression here and the least squares method. So if you're wanting workings, this is the first part of the workings.
Okay.
Right. Have you gone through this chapter in any detail?
Not too much detail. I just know the different methods and yeah, maybe not all the high, low, and all that stuff.
Yeah. Okay. Don't stress. Let's look at it. It's a short chapter. There's not much to cover here, but the basics are important because it's fundamentals that are carried through later on. Because remember, chapter 2 is only giving you a technique, okay, a way of estimating a specific slope, okay, or a line. All right. So let's look at this, and then I can explain what this actually looks at. Okay. So this is definitely a calculation, okay, in terms of workings. Right. You'll see here in the textbook they've given you an equation. Right, I'm going to give you this equation, which you might even recognize, perhaps, depending on how much of your maths at school you can remember. Y equals mx plus c. Does that ring any bells?
No,
Not really.
So yeah, but I could probably attempt to understand what it would mean.
Okay, yeah. So y is the independent the dependent variable. Okay, x is the independent variable, and then you've got an m, which is the slope of a particular line, right, a straight line, and then you've got c, which is the y-intercept. Okay, so when you look at linear equations, linear means straight line, so we're looking at something that looks similar to this. Okay, so I'm going to draw a quick little sketch here. Right, so we've got a y-axis and we've got an x-axis. Okay, x is the horizontal.
Yeah, y is the vertical.
And y is the vertical. Right, and then you'll have a line that can be drawn, which is a straight line, which can represent something. Okay, remember, maths can be applied in different areas. So in this particular area, we're applying it to management accounting. Okay, we're using it in order to predict costs and to allocate costs and to measure costs. Right, so just to draw a line, the line would look like that. Okay, just to add what we've identified here. Right, the slope of the line would be this, the actual line that's going up. Okay, so m here is positive because it's sloping up. Right, you can have m that's negative. If m is negative, then it's going to be sloping down. So you get a positive and a negative slope. So if I had to draw two lines, the one would look like that in terms of positive, and this one would be negative, and it will be sloping downwards. Okay, so that's important to understand in terms of the gradient, okay, the slope. If m is positive, it's upward sloping. If it's negative, it's downward sloping.
Yeah, right.
C is the y-intercept. Okay, so the y-intercept is basically where these lines touch the y-axis. Okay, so if I had to draw a little dot here, okay, that dot represents the y-intercept. This dot represents the y-intercept. Okay, it's the point at which the line touches the y-axis. Does that make sense?
Yes, 100%.
Okay. X is independent. If something is independent, it means you can substitute a number into it. So, when looking at equations, okay, this y equals mx plus c is an equation. The left-hand side must equal the right-hand side. Okay, so what this equation says is, if I've got the slope of a line, and I know what the x value is, because remember, we are at different points on this line. So if I know what x is, let's say I'm looking at x here, and let's say x equals 5. Okay, if x equals 5, that x5 is going to have a corresponding y value. Do you agree?
Yes.
Okay, because that's how we plot points on a graph. Does that make sense?
Yes.
Okay, so in order to plot that point in the graph, I need some value of x. Once I've got the value of x, I can substitute that into the equation and I can get y. So let's assume y equaled, let's just say 2x plus 5, just to keep it simple.
Okay.
Right, if I had to substitute x equals 5 into this equation, I'll have y equals 2 times 5 plus 5, which is 15. Does that make sense?
Yeah. I just want to ask, where did that, sorry, you said y equals 2x. Y equals 2x.
Plus 5. This is just the formula that I'm giving you.
Okay. So with the, okay. So the m would, so that, you're just saying m is equal to 2, just it's just a formula.
Yeah, it's just an example. I'm just giving you a formula to use, yes.
Okay. Okay, no, that's fine. Perfect.
Okay. Yeah, it is possible to work out the m, but we'll only look at that a bit later.
Yeah.
Okay. All right. So I'm just describing what the x and the y has in terms of relationship.
Okay.
Okay. So do you understand that? Can you picture that? Like, have a look. Yeah. If x is 5, what is y going to be?
X is 5, so y so would y be 15?
Yes. Okay, then you'd have 15 here where this line is. Does that make sense?
Yes. So you would basically draw it where it was, where you've drawn it, or on that line would be, yeah. So 15
it will be there.
Okay.
Okay, I'm just writing it here.
Yeah, no, that's fine. No, that's fine. So yeah, no, that's cool. That's fine. No, cool.
Right.
Perfect.
Okay, so just remember that when you look at straight lines, linear equations have different components. Okay, that's the one equation that we need to study and we need to learn. Okay, obviously the textbook gives it to you in a slightly different format. Okay, the textbook gives it to you in this format. They give it to you as y equals a plus bx. That's what they give you.
Okay. So then,
so the a is representing the y-intercept. Okay, the b is representing the slope.
Slope, yeah.
Which is basically the m from your mx plus c.
Okay.
Yeah, so I've just given you this because at school they would have talked about that formula. That's what they give you at school.
Yeah.
Right, this is what they give you at university because this is looking at linear regression. Right, and linear regression can be done on the calculator using the stats function.
That's okay. So I've got a financial calculator, and I've just got the Casio Natural V.P.A.M.
Is that a normal scientific?
Scientific, yes.
Yeah, that's perfect. Scientific, the Casios are very good. So if you've got the financial as well as the scientific, then that's good. What financial do you have? Is it HP or Sharp?
HP2B plus or HP2B plus or something.
Okay, yeah, it's the HP. Okay, that's fine. Yeah, HP is fine. You can use any financial calculator. You probably will use it later on, but not right now.
Yeah, no, you see, I got it for DSC. I got it.
Yes. DSC is a very good module, the 1630. That's a great module for doing financial maths. And if you can remember that one, they would have covered linear regression there as well, because there is a stats component part of that module.
Yeah, no, I do. I do remember that.
Okay, great. Okay, so that helps a lot if you know how to use the calculator's stats function. Okay. Everything happy so far?
Yes, very happy.
Okay, we need to write down an equation for m, which is the slope. Okay, so if I don't have m, I can actually solve for m. Right, when solving for m, you need a fraction. Okay, so I'm just going to draw a line here, just so I can show the numerator and the denominator. Okay, when working out m, you're going to need y2 minus y1, okay, over x2 minus x1. Right, and that's just the formula that's used to work out the slope of a particular line. Right, and you can see they explain that in terms of that high-low method. Right, high-low means you're going to look at the point that's higher and you're going to compare it to the point that's lower. Right, you need 2 points.
Yeah, okay. I think I did this also in ECS. Would that be economics?
ECS, yeah, economics, they cover supply and demand and that straight line, so yeah, it would be similar.
Okay, yeah, so it would be like it's new minus old or old minus new over old minus new.
Kind of. It's similar but not quite, because this is looking at points on a graph, not looking at old or new. That's like indices and stuff like that. That's not what we're looking at here. But similar.
Sure.
Okay. Alright, so you need 2 points to calculate the slope of the line. And once you've got those 2 points, you can actually calculate it. Okay, so let's see there's an example here. Yeah, there is one. On page 21, the activity here at the bottom of the page says during the 6 months ended June, these costs changed, but did not in a direct relation to the volume. Okay, so you can see there you've got month January, February, March, all the way to June. You've got the number of units produced, and you've got the historical costs. Right, are those units and costs going to be perfect in reality?
No.
No, they won't. Alright, so the reason why you have a scattered diagram is because when I look at this, let me copy this down here, okay. Right, in business, you keep track of different observations. Okay, in this particular example, on page 22, right, they've looked at the units produced and they're comparing it to the historical cost, so the cost, that's what they're looking at. Okay, so again, remember, anything that's observed is data. Data is just a collection of numbers that you can then represent on a graph. Okay, we can take numbers and we can do mathematics and we can present it appropriately. So if I look at units produced, let's put units produced on this axis. Okay, units produced, another word for that could be volume, could be output, could be just units. Okay, production. Alright, so obviously you've got an x-axis, and then on the left we have the costs. Does that make sense?
Yeah.
With me?
Yes, yes.
Okay. If I look at this diagram, right, you can see that if you look at the number of units produced, the smallest number here is 95, and then the biggest number here is 106. And then you've got historical costs which range between 1,950 all the way up until 2060. Do you agree? Matthew, are you still there?
Yes, I'm here. Can you hear me?
Okay. Right, so what do you see there? You see different points. So if I had to plot those points will be on the actual diagram, and they might look like this. Scattered. Does that make sense?
Yeah, not a perfect straight line.
Correct. Okay, so you would have covered something similar in DSC 1630, where they gave you like a scattered diagram, and then you would have had to find the formula of the straight line. But a line that best covers all of those points. If I had to draw a line, that line would be a pretty good estimate of where we would expect those observations to be. Does that make sense?
Yes.
Okay, and that's what you're looking at here. And that's what linear regression looks at doing. Okay, linear regression, straight lines. It's looking at creating a graph that's an estimate, a best fitting line that can give us what we think we'll get if I have an idea of how much units are produced. So if I can substitute the units produced into the formula, the y equals a plus bx, I'm then going to be able to identify the costs, right? Because remember, x is the units produced. So if I substitute x in using the m, which is the slope, as well as the constant, which is a, which is the y-intercept, I'm going to get the corresponding cost for that particular item. Make sense?
Yes.
Okay, and that's what you're looking at in this particular chapter. Right, so you said you're capable of calculating A and B on your Casio, your scientific calculator.
Yeah, so I can it is downstairs. Can I just quickly run and go get it?
Yeah, of course. Go get the calculator, and then we can do the working for the A and B for linear regression.
Okay, I'm coming back now.
Okay.
Okay, yeah, I've got it, yeah.
Okay. Which calculator did you bring? Did you bring the financial, or did you bring the scientific, or both?
No, so the scientific one was like near me, but I bought the financial one.
Okay, that's fine. That's good. You can use either or. You can do the stats calculation on the normal scientific, or if you prefer, you can use the financial calculator, which is the one that you would have probably used when you did DSC.
Okay.
So I'm just showing what they've got here: volume and then costs. Okay, so obviously you've got observations: 4,000, 3,000, 2,400, 4,400, 2,000, 3,600, and 2,200. Okay, then the costs, you've got 23,000, 18, 16, 24, 11, 23, and 15. Alright, so now the challenge is, can you get this? Y equals A plus BX. Okay, what does that represent? It represents a line that best fits those observations. Do you agree?
Yes.
Okay, right, so which calculator are you going to use? Do you need help working it out, or do you want to try?
You see, I can try. I do remember there is a mode where you can just go set up in the Casio calculator.
Yes.
And you can
Yes,
linear.
on the Casio. Matthew, what type of Casio do you have?
Okay. Can you show a video?
No,
four?
I want to bring a picture up so I can see what buttons you have.
Oh, okay. So it's the Casio, and then on the top corner, the model is the FX-82 ZA plus. Yes, correct. Okay, you got it. Cool. Yes, that one. That one exactly there. That picture. That first one. Yes.
Okay, I just want to blow up the picture a bit bigger so then I can see what buttons you can press.
Okay, sure. Okay.
Okay, so yeah, there's your calculator. Let me just see where the stats mode is.
Press shift. I think isn't it? Is it
Oh,
shift?
there's stats. Do you see it? There,
Oh.
on number 1.
Okay, so do I just press shift and then number 1?
Okay, so if you press shift 1, then you should get a stats like menu on the screen.
Yeah, it says result format, math 0, line 0. Was that
We're looking at linear regression, so choose line.
line? Okay, 2. I press 2. Okay.
And then what does it show you on the screen?
Just shows a normal screen.
Normal screen. Okay, let me try on this other Casio of mine. Let me just check here if I press stats menu. Let me just see what comes up.
Okay, well, I pressed it again. I pressed shift and then I pressed in shift setup. I pressed line IO. And then it just shows a 0 at the bottom.
Okay, no, you should get a menu. Let me just see what other buttons you've got here. Oh, okay. Do you see mode here at the top?
Mode, yes.
Okay, click that button.
Yes. Then press 2, stat mode. Okay, yeah, and then I get 1 equals variable cost or VAR.
1 minus VAR.
1 minus VAR,
and
yes.
then A plus BX.
Number 2, A plus BX. Correct.
Good. Okay, so that's the right option. So on your calculator, you need to click this mode button.
Okay, mode, just straight mode.
Yeah, and then you go into that option, then you can choose the second option, that A plus BX one.
Yeah, so I'll write that down. So it's mode, and then number 2,
and then you should see a column X and a column Y on your screen.
Yes, got X and I got Y.
Okay, then can you go back to this? Can you type in those things as is? So the first one is 4,000 for X.
Okay.
2,200 for Y.
4,000 for X. So when I press 4,000, must I just press the right button on the calculator on that little menu?
I think you should probably press equals, and I think it inserts it.
Oh yeah, it inserts it. Okay. And then must I just do all the X values and then the Y values?
Yeah, do all the X then, and then do all the Y. But make sure the right X goes with the right Y.
Yeah. No. Sure.
Okay. Do that quick.
Okay. 2, 4, 4, 4, 2, 3, 6, 2, 2. Okay. Let's go 1, so it's 2, 3. Okay, got it.
You got all of them in?
Yes.
Okay, so now let's just go back to that page. Okay, so, alright, so now you've typed everything into the calculator. Did you press equals on the last one? So everything's inserted. You can press these arrow up and down and you can see all the values, right?
Yes, correct.
Okay, great. So now that you've done that, okay, press AC.
AC.
And then press shift stat. Shift number 1.
Shift 1.
And then you should get a menu.
Yes, on the menu.
Okay, what menu items do you see?
I see 1 type, 2 data, 3 summary, 4 VAR, 5 regression, 6 min-max.
Okay, regression.
We're going number 5, okay. Then, then it goes number 1A, 2B, 3R, 4. And there's a symbol and 5 is another symbol.
100%, yeah. So you just want A and B. So choose A and then press equals. What do you get?
So must I press 1 and then equals?
What do you get?
So I press 1 and then equals, hey?
Well, choose the A and then it should bring up.
Bring up 29,2958.785.
Correct. That's the same answer as the one on page 26.
20. Oh, okay. I didn't hear. Let's have a look. 26. Oh, there. Yeah. 2958. Okay.
Do you see how they got that?
Yes. All right.
Okay,
so,
but
yeah.
now remember, your textbook does it the long way because they show the table to calculate it. In the exam, you can use your calculator because you'll have it. Doing it the table method takes too long.
Yeah.
Okay, you're not going to square all these things times all of it and all of that. It's just too much.
Yes. Right.
Okay, so you must know how to use the calculator to get the right answer. Okay, so then do that again. Go shift stat and then choose regression and then choose B. And what do you get for B?
I get 2958. Same answer.
No, go back. Do it again.
Oh,
B, not A.
I push B and then I press equals. Oh, B is 5.
Yes, that's right.
It's 5. Okay.
5.06.
Equals 5.0. Yeah, 5.059. 5.06. Yes.
Yeah, correct. So you can see where the textbook got those answers from. Makes sense.
Yeah, okay. Yeah. So they put the whole. Do they put the whole thing in? Oh no, they just. I think they round off.
They probably round off in the textbook. Probably, yes. Looks like they did.
Yeah, but okay.
Okay. But now, do you agree? You've got A, you've got B. Do you agree?
Yes.
Okay, so what can you do now? You can just rewrite that formula in the correct format. Does that make sense?
Yes. So So it would be your y-intercept is equal to 2958 plus, and then it would be 5.06x. Yeah.
100%.
Well, it is plus. Yes, it's plus.
Okay. Happy with that section?
Yes.
All right, and that's section 2.
So then, I did write down the steps of the calculator, so it will just be mode, stats, and then I would just put all
Okay, redo, Matthew. Okay, let's do one. Let me check for another one. Okay, here's one. Do the one on page 29. Okay, let's practice. Go page 29.
Oh, okay, this whole big one here.
Yeah, put that into the table, and let's see if you can get the A and the B, but on the calculator. Don't draw a table to do this.
Yeah, no, I'm gonna do X. Okay, so number of bags manufactured would be X, and then the overheads, the cost would obviously be the Y slope. Yeah. So 360. Oh no, wait, it's 360. 375. Okay, let's get to number 1 on the Y.
So remember to the mode button first, eh?
Yeah. Okay, and then so then I just quickly forgot that you put to do it. You pressed the AC.
Okay, hold on. What did you do? Did you type in all these values?
Yes, I typed in all the values.
Okay, and then all the values, and the last one you press equals. Then you can scroll up and down and look at them, right?
That's correct. Yeah.
Okay, so after that, yes. Then you press AC, and then you press Shift.
And then number. Yes, and then we want to look for number 5, and then we're going to go number 1, and then we're going to say equals. Number 1 equals 86.88.
Let's check in the textbook. What did you say A was?
I said 86.88.
Let's see what they've got here. They've got 868.
868.
Did you put in all the values correctly?
Yeah, let me just go back. Let me
do it on my calculator and see. I think I can actually work it out here. Let me check if I can do it on Excel. A equals. Just check your calculation. I think something went wrong.
Yeah, let me just go. Oh, I think I just cancelled everything. Oh no, I didn't. How would you go back to that table?
To go back to the table, you need to go back into the mode. So mode again.
Oh, mode, and then you just say, table 3. Okay. I know.
No, A plus BX.
Oh, okay. Shift. Okay. Oh yeah, I think I just cancelled the whole thing, but I'll do it again. Is it the one on 28 or 29?
Which one?
29. No, it was the right one we were doing. Page 29.
Page 29. Yes. Yeah. So okay, quickly do it. Let's just check. I'm going to do it on my calculator. Let's just see what we get. Okay, so stats mode. Okay, so I've put everything in AC. I'm going to solve for.
So then, and then after you push AC, you press Shift Stat, hey?
After you press AC, Shift Stat. Yeah, Stat. Shift number 1 on your calculator.
Then number 5. Regression.
Yeah, then choose A. Okay, yes, I'll actually get the same thing. I get 86.88, 183,137. That's what I get on my calculator for A.
Okay, for A, I've got 87.501 now.
No, it should be the same. I think your numbers aren't right.
Maybe I'll just put in an extra 1 or something.
But if I look at the answer, number of bags manufactured, let's have a look. Maybe these bags were grouped into tens. Let's just check. Is there anything here? No, just number of bags. A is 86, yeah, because if you look at their answer, they've got 868. Their decimal's incorrect. Do you see that?
Yeah.
I think they might have made a typo, an error with the working year.
Yeah.
Okay, because they've got this in your textbook. They've got 868, comma 824. Right, so I think they've made a mistake with the number, the decimal.
Just the decimal.
Yeah, just the decimal, but the number looks right. Okay, let's quickly solve for B. Shift stats.
Okay, shift stats.
B, I get 0.3.
0.3. Same.
Yes, okay, so B here, 0.3104949,218. That was for B. Okay, so that was for B here. And B in this particular question, they said use the scatter diagram to calculate the budgeted semi-variable manufacturing overheads if $385 were manufactured. $385 were manufactured. So you have to substitute that back into the equation. They've shown you the high-low. Okay, that's just the gradient. They've worked up the total budgeted semi-variable cost. That's fine. Okay, then they've got the least squares method, and then they've got the A and the B at the bottom here. Substitute the values in. Let's see. This was for how many units? Total budgeted variable semi-variable manufacturing overheads for 120 bags per month. Okay, so that they didn't mention in the question. They mentioned in the question, but it's not on the table. Do you see that?
Yeah. No,
Just look at question B. There's a part that we're missing. In the question, they say 120 bags manufactured. See, use the least squares method to calculate the budgeted semi-annual manufacturing overheads if 120 bags are manufactured. Right, so if we're buying 120 bags, then we're looking at the number of bags manufactured. This is the estimate that we've got currently in terms of data. So we've got an A and we've got a B. Then they're replacing B with that 9 Rand 31 because they've done this equation here, this y equals x and y equals for the simultaneous equation on the second page. Yeah, this is actually a longer question. It's not a one-step question where you just work out the A and the B.
Yeah. Okay.
Okay, but let's see if there's a different one. No, these are the only two examples that they've given you. Question 1.
It's fine. I definitely can go over it. I mean, I've got a vague understanding now of the first part. So
Matthew, we've looked at this page 29. If you look at page 28, 28 is the one that you get those other measures.
So A and B.
Yeah, because the A and B is for the other one. See? Do you see that?
Yeah.
Okay, so quickly do this one. Just type it into the calculator. 120, 130, 125, 115.
Oh wait, I just want to get out of stat mode.
Just reset the calculator or clear it, and then type it in again.
Cool. Okay.
Do you know how to reset the calculator?
Yeah. So I did it. Thanks.
Yeah, so these are the right numbers that we need to put in for the right question.
And can you just move your cursor from the second? Is that a 0? Is it 2000?
It's 2000, sorry.
No problem.
Okay. There we go. Okay, right answers. I'm getting it.
Yeah, okay. So I've got 868 for the first one.
Perfect. Yeah, so we were just reading the answer for the wrong question. It was question 1, not 2.
Okay, so okay, makes sense.
Okay, so A here is 868.1883137 ...
Yeah, okay.
Okay, then if we just go shift stat menu 7B solve, yeah, you get the 9.31. It is correct. The textbook's right. Nothing wrong with the book.
Yeah, 9.31. Also got that.
Okay, good. Okay, happy with this?
Yes, happy.
Great. Okay, so anything linear regression related, just grab the calculator, do the workings, and solve for the correct variable.
Yeah, mate, that's fine.